In this era of technological development, large language models are changing our lives. Whether it is content creation or scientific research, large language models are used in various fields. Many developers will think about whether large language models can run on edge computing devices with limited performance. Can the GPU of edge computing devices meet the needs of using large language models? Can we achieve the same smooth conversation experience when interacting with ChatGPT as PC computers? Edge computing devices with built-in GPUs like NVIDIA Jetson can significantly reduce computing time when processing large-scale data sets and complex algorithms. When we interact with ChatGPT on a computer, we are actually conducting a remote conversation in the cloud through the API interface on the web page. Therefore, the heavy computing tasks of these models are undertaken by GPU clusters on the server side rather than being executed directly on the local computer. Edge computing devices can also conduct remote conversations with the cloud. In application scenarios where there is no network environment, privacy protection and mobility are required. Local deployment of edge devices demonstrates irreplaceable value. Today, we will take Jetson Orin NX 16GB and 8GB versions as examples to test offline large models released by different companies. For example, Qwen 2 developed by Alibaba Cloud, Gemma developed by Google, Phi 3 launched by Microsoft, Wizardom 2 launched by Microsoft, and Lava, etc. Next, we will run these large models offline on Jetson Orin NX to verify the feasibility of deploying large language models on high-performance embedded devices, such as Jetson Orin NX. Due to the high computing power and performance of Jetson Orin NX, almost all models can respond within 2 seconds, which is much better than Raspberry Pi. We prepared 5 questions to test the text processing speed, response logic, and accuracy of these models. First, let's look at the Qwen 2 7 billion parameter model developed by Alibaba Cloud. The text processing speed of Jetson Orin NX 16G is 10.2 tokens s. The text processing speed of Jetson Orin NX 8G is 4.2 tokens s. The response accuracy is relatively high. Phi 3 8 billion parameter model from Microsoft. Since the model is smaller, the text processing speed of Jetson Orin NX 16G is 18.5 token s. The text processing speed of Jetson Orin NX 8G is 17.5 token s, which is not much different. The response accuracy is high, and reply content is more. Gemma model developed by Google. Since the 7 billion parameter model cannot run on Jetson Orin NX 8G, we use 2 billion parameter model for testing on Jetson Orin NX 8G. The text processing speed of the 7 billion parameter model on Jetson Orin NX 16G is 10.3 tokens s. The text processing speed of the 2 billion parameter model on Jetson Orin NX 8G is 19.5 tokens s. The overall response content is relatively brief. 7 billion parameter model responds slower, but the response effect and accuracy are better than the 2 billion parameter model. Microsoft's large language model Wizardom 2 has 7 billion parameters. The text processing speed of Jetson Orin NX 16G is 13.1 token s. The text processing speed of Jetson Orin NX 8G is 6.4 token s. There is an error in the answer to one question. The accuracy is not high. The last model tested was the Lava 7 billion image and text multimodal model. Combines visual recognition technology with the Llama language model. Not only good at processing language information, but also can simultaneously analyze visual content, enter the image link in the dialog interface to perform image analysis, and output text results. For this test, I prepared a picture for a question and answer test. The text processing speed of Jetson Orin NX 16G is 13.5 token s. The text processing speed of Jetson Orin NX 8G is 3.7 token s. The content of picture is analyzed correctly. In addition to the above models, we ASLO tested other models. However, these models had many wrong responses and are not recommended for use. The test comparison results are shown in the table. Based on all our test results, we can draw the following conclusions. Large language models can be run on edge computing devices with limited performance, but the effect of using offline large language models is not as smooth as cloud-based conversations. 7 billion model runs much slower than the 3 billion and 2 billion models, but its response accuracy is better than them. In the future, the application scenarios of large language models will become more and more mature, and even combined with visual and audio technologies. We will see some solutions being applied to edge devices, such as Jetson, such as offline voice assistants, personal butlers, conversational robots, tour guide robots, and more.